Again, if you haven't checked in, I think everyone has, but if you haven't, please do so. Uh, Today, a couple things. One, we're going to review everything we've done so far, as you can see kind of on the screen that you have in front of you. Okay, I do want to go over a couple of questions on R7 and R8. I will say that if you have like a specific question, which work way better than really super general questions, like how do you do this? I don't understand it. Um, Give me a specific instance of a question. If you screenshot a question that you are totally unsure of how to do it, I can do that for you, and it'll quite often help other people. Okay, so the more that we can do that, the better that this will be. All right. Second, and before we do that, um, I do kind of pay attention to who's actually watching, uh, and it's really important that you do, because if you miss one of these, you technically miss a class. Even if you checked into to on campus and all that, you do technically miss a class. All right. Um, these are really important, and I have a feeling that some people who don't understand this stuff have just not asked any questions or have shown up to the meetings on Teams. Okay, that's another important thing. This class is two parts. Okay, there's the lecture part, and then there's the Teams part after where I can help you one on one. So if you have a bunch of questions, like the day or the night before this stuff is actually due, um, most of the time I can help you right after the lecture. All right. Um, that's just it's something that I built in here to help you. But if you're not taking advantage of it, not only are you doing yourself a disservice, I don't know what people are not understanding, which is part of the reason I'm giving these discussion questions. All right. So, with that in mind, I want to quickly kind of go over what we've done so far with Trig. I want to go over one example problem, which seemed to get most of the other classes' questions answered. All right. And then we're going to kind of tie all this stuff together, and I'll let you get going on your homework. So, first, everything we've done so far. It's pretty much on your screen, really. And obviously, it can be a little bit more complicated that way, what you see, but this is most of it. All right. So, from a right triangle, we've named sides based off of a given angle. So, we've found the opposite side, we found the adjacent side, we found the hypotenuse. Um, that's like one of the most important things you can be able to do. All right, is just name sides, because usually if you can name sides and you can spot your angle, you can at least start most of the problems that I'm going to give you. Okay. Besides that, we went over trig, some of these trig functions. Okay, so Sohcahtoa. Um, Basically, all this means is that every angle has a relationship with different sides. So the sine relationship of theta, that's going to give the ratio of opposite and hypotenuse. The cosine relationship is going to give the relationship of adjacent and hypotenuse. And then the same thing with tangent, except it's opposite and adjacent. Okay, so that's trig, all right, in a nutshell. And then with that, we also went over the Pythagorean theorem, which we actually went over last chapter as kind of a preview to what we'd be doing this chapter. So that's adjacent squared plus opposite squared is the hypotenuse squared, which a lot of you know is a squared plus b squared is equal to c squared. That's fine. I like to keep these as consistent with what we do up here as I can. That way you guys know exactly what we're talking about. Should we write these down? No, you don't have to write these down. This is just a kind of an overview of what we've done. If you want to, go for it, but you definitely don't have to. Okay. Besides that, we went over reciprocal functions. So cosecant, secant, and cotangent. It's exactly what it says in the name. They're reciprocals of the trig functions that we've already known. So cosecant is just the reciprocal of sine. So the cosecant relationship with theta, that's hypotenuse over opposite. The secant relationship with theta, that's hypotenuse over adjacent. And then cotangent relationship with theta, that's adjacent over opposite. Okay. After that, we did inverse trig. And basically all that means is that we're undoing the trig function in order to get theta by itself. So whenever you solve for an angle, you'll be using inverse trig. All right. So the thing that's kind of highlighted, Sine inverse of sine, that undoes itself, both of the sines, in order to get just theta. Okay, the inverse cosine of cosine, that undoes them both, and we just get theta. The inverse tangent of tangent, that undoes both of them and then gets tangent. Okay, so again, we'll go over examples of this here in a second. But in order to actually solve for an angle, you're using inverse trig. And then we went over some problems where we actually had to get a rational and simplified answer, in which case we used these bottom 9 values down here. Okay, and again, we'll be using that here in a minute. But that's really just glorified substitution. So if you ever see the cosine of 45, right, we're just going to substitute in rad 2 over 2, and then from there it's a normal problem. Okay, and I think that was kind of the harder part that some people were asking questions about. And I will go over an example here that, again, will answer most of your questions, but those bottom 9 values are important. If you ever see like cosine of 30 or cosine of 60 or sine of 30 or tangent of 30, those values, you will be using those. Okay, and within all of that, while we were doing all of that, we were rationalizing fractions and in general just dealing with square roots. Okay, and I realize that's also probably one of the harder parts. But it's something that we need to know not only for this, but for future chapters, for future years in calculus and pre-calculus and algebra 2. You're just going to have to simplify square roots. And the quicker that you're going to be able to get that, the better you're off you're going to be. Okay, so that's pretty much everything we've done so far with trig. And again, I know that sounds like a lot, but the more you're able to break these problems down and just label what you know and what you don't know and what you need, the better off you're going to be able to do it. Okay, and again, I get that seems simple on the surface, but it can be tricky, and sometimes you have to maneuver a little bit. But all this is that we're doing is practice. Okay. So with all of that, I want to go over one question that's from R8. Okay. Which will hopefully answer a lot of your questions, which were a lot of the same questions that I saw from the last class. What does Sohcahtoa stand for? Sohcahtoa is, so I'm going to start in the red. So S, sine, is opposite over hypotenuse, right? Cosine in the blue, that's adjacent over hypotenuse. Tangent in white, that's opposite over adjacent. It's just an acronym so you can determine what the ratios are. If you don't know that, that's okay. If you don't know Sohcahtoa and you know this, you're fine. You don't necessarily need to know Sohcahtoa. It's just a shortcut. Okay. So, for example, hopefully, again, this answers a couple of your questions. In your homework, you are given a triangle that looks like this with an angle of 36 degrees and a side length of 5. Okay, and we want to find QR. The first thing that we should always do, or at least one of the first things that we should always do, is just label the sides. All right. So if we draw a line from the angle that we're given to the other side of the triangle, that's our opposite side. If we draw a line from our right angle to the other side of the triangle, that's our hypotenuse. And the remaining side is our adjacent, which is also always the side attached to the angle that's not the hypotenuse. If you don't know that, that's okay. The way we just did it will help as well. Okay, so we are given the opposite side and an angle, and we're trying to find QR, which is the adjacent side. Okay, so we're trying to find the length of that blue side that I just have highlighted. In order to do that, we have to take what we know and plug in what we don't know, and try and find what we don't know. Okay, so we're given opposite and adjacent, and the only trig function that has opposite and adjacent in it is tangent. So we're going to have to use the tangent of our angle in order to find the adjacent side. And again, we're using tangent because we're given opposite and we need to find adjacent. So if we set up our equation, tangent is opposite over adjacent. So then we can just fill in what we know. So tangent of 36 is equal to opposite, which is 5, over adjacent, which is unknown. Okay, so quickly, I want to pause. Again, this we should absolutely have down, no matter what. If you don't have this down, we need to catch you up, because this is like the fundamental part. Are there any questions over anything we just did right there? All right. Now is when we have to do a little bit of algebra. Okay, so what I like to do is I like to get the adjacent side by itself first, or the unknown side of what we're going to solve. And a lot of people from on campus and from the last class, they're a little bit unsure of what to do when our unknown is in the denominator. Okay, and we should be able to do this. We worked with proportions earlier on in the year, specifically for stuff like this, so we'd know what to do. And in order to get something out of the denominator, which is what we need to do, we'd multiply both sides by that denominator. And what that does is it cancels out everything on the right except for the 5. And then we have the adjacent side times the tangent of 36 is equal to 5. Again, this is just basic algebra with a couple more letters involved than normal. Okay, adjacent and tangent. Then, in order to get the adjacent side by itself, we have to divide by what it's being multiplied by, which is the tangent of 36. So we have to do that on both sides. And again, on the left-hand side, the common factors cancel. And we're left with the adjacent side on the left-hand side is equal to 5 over tangent of 36. So again, I want to pause there and just make sure everyone understands what's actually happening. Why do you use adjacent instead of hypotenuse? We're using adjacent because, one, that's the side we're trying to find. And hypotenuse isn't involved in the tangent. It's not a part of the tangent ratio. Okay, so tangent is by definition opposite over adjacent. So our denominator is adjacent because it just goes along with tangent. Are we going to have quizzes and tests? Yes, you will have quizzes and tests. Okay, so again, are there any questions over what I did algebraically in order to get adjacent side by itself? Why are you waiting to convert the tangent of 36? It ends up being just easier to round and a little bit more exact. I like to do that as the last step so I don't screw anything up. Because if you convert the tangent of 36 into a decimal, which is what it will be, suddenly you're dealing with like maneuvering around a 5 decimal place number. And to me, that's just, it's not worth the hassle. It's just easier to convert it later. You can, you just got to be really careful with it. Basically, I like to have all my algebra done before I go to a calculator. That's like my real issue. Okay. Now we need to actually get an answer. So we have the algebra done. Now we need to get an answer. How do you know when to use tangent or sine for these problems? You know because of how we labeled the sides. So we have the opposite side, we don't have the adjacent, and that's the side that we need. And the only trig function that has tangent, or that has opposite and adjacent, is the tangent. So now we need to convert this into an actual like number. All right, so I'm gonna get Desmos open. All right, and in order to get a number, I'll show you on Desmos and then kind of talk you through using your TI-84 or TI-83. On Desmos, it's really easy though. Because we already have this solved, we just do 5 and then dash, type in tangent of 36, and that'll give us a number. But we have to be really careful about what type of number that is. Okay, so in order to make sure that this is in degrees, we have to go to this wrench icon up top right, click it. At the very bottom of this tab that opens is a radians and degrees option. We want it to be in degrees, so click over degrees, click on it, and the answer will be what we want it to be. Okay, so the answer to this entire problem is just 6.88. Now, on these IXLs, it tells you exactly what you need to round to. Okay, so if you need to round to the 10th, then I would have to round this up to 6.9. If it said to round to the 100th, it would be 6.88. If it said to round to the 1000th, it'd be 6.882. Okay, so you have to be really careful about what the directions are actually saying. I know it's tempting to just go into a problem, ignore the bottom like fine print directions, and then just brute force it. That's not always going to give you the right answer. Sometimes you actually do have the right answer, you just haven't rounded it correctly. Okay, so you need to be very careful about what the directions are actually saying. So there are a couple things that this problem was supposed to cover. And before I get there, I want to pause just for another second. Are there any questions over what I just did? On a TI-84 or TI-83, you'd pretty much type it in exactly as I have it up on the screen here. Again, I like to have my numerator in parentheses and my denominator in parentheses, but other than that, it's pretty much the same. So you do 5, hit the division side, and then type in tangent 36, hit enter, and you'd get an answer. On your calculator, in order to make sure that it's in degrees, you hit mode, scroll down to radian and degree, make sure degree is highlighted, hit enter, and that'll have it in the correct mode for you. Round to the nearest 10th or 100th. Again, it depends on the question. You gotta just read the directions that come with the problem. So sometimes we multiply and sometimes we divide. Again, it depends on the problem. If you're solving for the denominator, then you have to maneuver it just like we did. If you're solving for the numerator, or for the numerator, it's a little bit easier. Again, that part is very much just algebra based. Okay, so that's kind of why we worked with proportions a lot before spring break, uh, because we're going to be dealing with them a lot from here on out. Okay, so that part is very much algebra based. So you got to be very, very careful about what we do. Okay, I think that answers most of the questions. Um, if there are any more, please let me know and I can help you out with it. For now, though, I'd like to move on into this next homework piece so you can actually show you what's going to happen. Okay. Um, and we're pretty much just going to be tying in most of what we've done so far. All right, and it's gonna look like solving right triangles. So the directions are going to say solve for a certain angle, solve for a certain side, or just solve the right triangle. Okay, so from here I have an example directly from the homework. Okay, and given this right triangle with sides square root of 21 and square root of 15, we want to find the measure of angle V, and that is a V, not a U. And I believe the direction said to round to the nearest tenth. So in order to do this, again, the best thing that we can do is to mark what we have, mark what we don't have, and mark what we need. All right. So we are trying to find the measure of angle V, which if we just mark that on our triangle, it's this angle right here. And as soon as we have that, then we can label the sides that we actually have. So if we draw a line from that angle to the other side of the triangle, that's our opposite side. If we draw a line from our right angle to the other side of the triangle, that's our hypotenuse. And then the remaining side is our adjacent. So if we just look at what we're trying to find an angle, and we have the opposite side and the hypotenuse. Okay, so again, if you look at Sohcahtoa, we have the opposite side and the hypotenuse, so we should be using sine. Okay, so if we set up our equation, the sine of our unknown angle is going to be equal to the opposite side over the hypotenuse. And then we can just substitute in what we know. So we still don't know theta, so that's going to stay the same. The opposite side is the square root of 15, and the hypotenuse is the square root of 21. So again, this is kind of the fundamental part, is just setting that stuff up. Are there any questions about that? All right. So now, keep in mind that our question is to find the measure of angle V. So we need to solve for theta in this case. All right. And in order to solve for an angle, we're going to have to use inverse trig. So in order to get theta by itself, right? So right now theta is not by itself. It's attached to this sine. And in order to undo that sine, we have to take the inverse sine of both sides. Right? Because what we do to one side, we have to do the other. And when we do that, on the left-hand side, both of those signs cancel, and we're just left with theta. And on the right-hand side, we still have just sine inverse of root 15 over root 21. Which, honestly, if we get to that point on a test or a quiz, and I'm asking you to show your work, that is what I want to see. That is exactly what I want to see. If you can get to that point, you've done it perfectly. Okay? The rest is calculator work. Okay? And you might be asking yourself, well, there's a square root in that denominator. Do we need to rationalize that? And because we're going to be using a calculator and that's going to be doing it for us, no, it can stay like that. Okay? Because that's not our final answer. That's just kind of a means to an end. So again, are there any questions about what I did in those last two steps? Okay, so now we need to make that sine inverse of the square root of 15 over the square root of 21 into a number, right? Because we're trying to find an actual angle. So if you have a TI-84 or a TI-83, what you would do is hit the second button and then the sine button. And then I always have parentheses around the numerator, so I would open another set of parentheses and then type in the square root of 15, close that set of parentheses, divided by, again, open another set, square root of 21. Close that set, and then close it overall. And we should get 57.68 which rounds up to 57.7. So again, on your calculator, second sine, and then we have to type in the square root of 15 in parentheses and the square root of 21 in parentheses. On Desmos, so if you do not have a calculator, or do not have a TI-84 or 83, in order to type this in, go to our keypad, hit functions, find the sine inverse, and then type in square root of 15 divided by the square root of 21. And we get the same answer. So, questions about this problem? All right, I want to do one more problem kind of like this. All right, again, we're trying to find an angle. We're trying to find angle J in this case, given this figure with sides 2.5 and 3.3. So again, just like every problem we've done so far, the best thing to do first is to just label what we need. So we're trying to find the measure of angle J, which is this angle right here. And then we can label our sides. So if we draw a line from that angle to the opposite side, that's our opposite side. Draw a line from our right angle to the other side, that's our hypotenuse. And the remaining side is our adjacent. Again, being able to do that is like a prerequisite for everything that we do from here on out. Now, we need to think about what we have and think about what we don't have. Okay, so in this problem, we are given the hypotenuse and the adjacent, and we're trying to find this angle. Okay, so given the adjacent and hypotenuse, if we think about Sohcahtoa, the only trig function with adjacent and hypotenuse in it is cosine. So if we set up our equation, we have the cosine of our angle theta, which is what we're trying to find, is equal to 2.5, our adjacent, over 3.3, our hypotenuse. And then from there, again, we're trying to get theta by itself, so we need to do a little bit of inverse trig. So in order to undo cosine, in order to get this theta by itself, we have to take the inverse cosine of both sides. Oops. And when we do that, these two cosines will end up canceling. So cosine inverse undoes cosine. So we're just left with theta. And then we have the inverse cosine of 2.5 over 3.3. So again, if we do that on a test or a quiz, that is 95% of the points right there. Okay. But we want to get a number for that angle measure. So in order to do that, again, on a TI-84 or TI-83, you would hit second cosine, and then 2.5 divided by 3.3. And if we want to round that to the nearest tenth, we'd get 40.7 degrees. On Desmos, go to functions, find the inverse cosine, type in 2.5 divided by 3.3, and we get the same answer. So again, I want to pause there. Are there any questions over the last two problems? Anything that you saw? this example and then one more. All right. So this is a kind of a different type of problem. And what this problem will say is to just solve the right triangle. All right. And there will be three options that you can fill in. So we're trying to find two sides in this case and one angle. Again, the first thing that we can do is just label our sides. So we have this angle. If we draw a line from that angle to the other side of the triangle, that's our opposite. If we draw a line from our right angle to the other side of the triangle, that's our hypotenuse. And the remaining side is our adjacent. Okay, that's the easiest thing that you can start a problem with, is just labeling the sides. All right, and then we have to look at what we're actually being asked to find, okay? So we want to find AC, which is the hypotenuse right here. And we want to find AB, which is the adjacent side. And we want to find the measure of angle C. And the easiest thing that you can do is to find the measure of a third angle. So we should know that the sum of all angles within a triangle add up to 180. And we know two angles. All right, so we know that 30 plus 90 plus our angle C is equal to 180. So then we can do some simplifying and some algebra in order to solve for that. And then we have to solve for those two sides. All right, so I'm going to solve for AC first. I'm going to solve for the hypotenuse. So we are given the opposite side, and we want the hypotenuse. And the only trig function with the opposite and the hypotenuse is sine. So if we set up our equation, we have that the sine of 30 degrees is equal to our opposite side, which is 5, over our hypotenuse. And then we need to do some algebra just to get hypotenuse by itself. And when we do that, these two pretty much switch sides, or switch positions. So hypotenuse will equal 5 divided by sine of 30. And then we have hypotenuse solved for. We just got to simplify our answer. Okay. Now, because we have a 30-degree angle, we have that sine of 30 is actually equal to 1/2. So we can substitute in sine of 30 for what it actually is. So hypotenuse will actually equal 5 over 1/2. Which, again, you can plug into a calculator, but you should know that if you are dividing by a fraction, so when you divide by a fraction, you are really multiplying by that fraction's reciprocal. So this hypotenuse is actually equal to 10. So I want to pause there real quick. Is there any question over what we've done so far? Is it just all the things we learned into one problem? Yeah, you can use everything. You don't necessarily have to, and that's both good and bad thing about these problems. There's a lot of different ways to solve these, which I'll show you in a second. Um, and there's a lot of different there's just a lot of different ways you could solve it. Okay, so if you're stuck on one type of problem or one type of way of doing it, sometimes in other ways a little bit easier. Right? For example, since we solved the measure of angle C is actually 60, we could actually be using this angle the entire time and totally ignore our 30-degree angle. So instead of using that 30 degrees at all, we could be using angle C. Now we'd have to label our sides differently, but we could do that. Okay, and on this next part, so if we want to solve for side AB, that adjacent side, there's a couple of different ways we can do that. Is it a problem that I have a TI 30x? I don't think so, unless it's not able to do degrees. In which case, if it doesn't, go to Desmos. Okay, so in order to solve for this AB, this adjacent side, there are two different ways we could do it. And there's actually more than that, but in order to just keep things simple, I'm going to keep it to two. All right. We could set up a trig function, right? So we could set up the tangent of 30 is equal to the opposite side over the adjacent and solve for that. We could also do the opposite squared plus the adjacent squared is equal to the hypotenuse squared. All right, so we could do 5 squared plus the adjacent squared is equal to the hypotenuse squared. And we could solve it that way. And really, we could also do cosine of 30 is equal to the adjacent over hypotenuse, which is also 10. Okay, so there's a lot of different ways you can do this, and really it's whatever you feel most comfortable with. So if you feel more comfortable with the Pythagorean theorem, go for it. If you feel more comfortable with the tangent of 30, it's all the same. Okay. I'm just going to pick one. I'm going to make some room for myself. So I'm going to use the tangent of 30 because you can start there if you wanted to. The only reason you can do those other two is because we're given more information, or we found more information. All right, so I'm going to use that tangent of 30 because that's, again, you could start from there, step one, if you wanted to. So the tangent of 30 is equal to 5 over the adjacent. The adjacent then is equal to 5 over tangent of 30. From our values, we know what the tangent of 30 actually is. So then the adjacent side is equal to 5 divided by root 3 divided by 3, which we then have to simplify and rationalize. And then once we get there, we'd have to rationalize it. So then our answer is 5 rad 3. Okay, that actually took longer than it would had I just done the cosine of 30. So again, different ways yield different results. I mean, it's all going to be the same answer, but there's slightly different ways to do it. Okay, so because 10 is in the denominator for this cosine of 30, we could actually just multiply cosine of 30 by 10 and be done, which ends up looking like this. So rad 3 divided by 2 times 10 is equal to the adjacent side. And when we simplify that, 10 divided by 2, that's 5. So we just get 5 rad 3 is equal to the adjacent. Same answer, different way of getting there. And I'm looking up, and I realize, why isn't it just 5? Because it doesn't simplify to just 5. There's that rad 3 there. Because you have to end up on this right-hand side, you end up having to rationalize this. If we did Pythag, it's still going to be 5 rad 3. Because you'd have to simplify the square roots. Okay. But I'm looking up and I realize that there's a whole lot of writing up here. I also did things 2 different ways and I have all those values up there. I want to pause for a second. Are there any questions that you are totally unsure of? Okay, again, if you're not sure, you definitely need to ask. If you don't want to ask now for whatever reason, I can also help you in Teams later. Okay, but I do want to go over one more example that is actually slightly easier because we don't have to worry about rationalizing. Again, the directions just say to solve the right triangle. And like always, we're just going to label our sides. So after we label our sides, we can start to find different values. Okay. Again, I always like to get this measure of angle J out of the way. So you're saying that we only have to do one of those 3 ways. On that problem, you still have to solve for each of these things, but you only have to do one way in order to solve for them. So on that last part, that last side, I solved it 3 different ways. You only have to pick one. Okay. But again, solving for the measure of angle J, that should be the easiest thing that you do because we know that 22 plus 90 plus angle J is equal to 180. So that's the first part of our answer. Again, that's quick and easy. And then we can start solving for sides. All right, so I'll solve for JK first. And I'll do that in white. All right, so in order to solve for JK, we have the opposite side and we don't have the hypotenuse. Okay, and the only trig function with both opposite and hypotenuse is sine. So we would take the sine of our angle is equal to our opposite side, which is 2, over the hypotenuse. When we multiply the hypotenuse on both sides and then get the hypotenuse by itself, it ends up being that the hypotenuse is equal to 2 divided by the sine of 22. And then we can plug that into a calculator and get an answer. So on your calculator, I would do 2 divided by, and then open a set of parentheses and type in sine of 22. And we end up getting 5.38. And this would say to round to the nearest tenth. So it would just be 5.3. And the reason we don't have any radicals or anything in here is because we're dealing with an angle that isn't 30, 60, or 45. And then we can solve for ik, which is the adjacent side. So in order to solve for ik, again, we have the opposite side, and we need the adjacent. And the only trig function with both the opposite and the adjacent is tangent. So the tangent of our angle would equal our opposite side, which is equal to 2, divided by our adjacent side. Again, when we do some algebra, we would get that the adjacent side is equal to 2 divided by the tangent of 22. And again, we'd plug that into a calculator or Desmos. So 2 divided by tangent 22, and you get 4.95. If that said round to the 10th, it'd be really 5 even. All right, so I went over this problem a little bit quicker. Again, there's not as much involved in this because you don't have to rationalize, you don't have to deal with square roots. So it's in some ways it's a lot nicer to have an angle that isn't 30, 45, or 60. Okay, but I'll pause there for a second. Are there any questions over this problem? All right, so if you do have questions, I will leave this open for the next minute or two. Any general questions that can be asked, again, that's great for this. If you have specific questions, I will be on Teams in the next 5 or 6 minutes, and I will help you there. All right, again, this class is 2 parts, right? It's this lecture, but then it's also Teams and a meeting. Okay, am I expecting you to be there? No, but if it turns out that more and more people are needing help and not actually asking for it, then I will require it. Okay, I don't want to do that. I don't think I should have to do that. But if I need to, I will. All right. So your homework is R9 and R10, and I fully expect that you actually start to do it. So if you have any questions, you can ask me. Okay. So again, I'll leave this open for the next minute or two. And if there's no questions on here, I'll start a meeting on Teams, and we'll go from there. All right, since there are no other questions, I'm going to end this. And if you do have other questions, I will be in Teams and we'll see you there.